Hello everyone, welcome to the Makri Virtual. Hope you are doing good. Today I am going to continue with your same topic, that is same chapter, that is machine level representation of programs. As the name advises, machine level representation means how we can represent the program with the help of machine code, that is zeros and ones. Till now we have discussed multiple topics, that is total 9 topics: pointers, array, multiple operators, conditional operators. All that we have covered in this chapter IA32. Now I am going to continue with your next topic, that is x86-64. That is an enhanced version or the advanced part of the IA32. But before that, let's take a quick review of the previous class, that is yesterday's class. So let's take a quick review. In the last class we have discussed about the GDB, that is your GNU or GNU Project Debugger. What is GDB? It is a GNU Project Debugger that allows you to see what is going on inside another program while it executes. That is how it executes and how it allows you to see what is going on in the program, means to debug or to find the error inside the program. That is done by the GDB Debugger or GDB. So that is GNU Project Debugger, that is used for debugging the program, for finding the program, so that program will execute at a proper optimization, proper efficiency. This is the program being debugged can be written in ADA, that is Advanced Digital Algorithm, C language, C++, Objective-C. Means it can debug, or the program can be debugged or being debugged can be written in any language. It may be C, it may be C++, it may be Pascal, it may be Objective-C, any type of programming language, but GDB debugger is used for debugging the program, finding the errors in the program. Then we also studied what are the 4 kinds of main things or 4 kinds of main support that is provided by the GDB. First of all, it starts your program specifying anything that might affect its behavior. Then make your program stop or specify conditions. Then examine what has happened when your program has stopped. Then change the program if there is any requirement for the changing the program. That is also done by the GDB debugger. Then how GDB works or how GDB debugs, it allows you to run the program up to a certain point. Means it works by inserting the breakpoint to the certain points or the breakpoint to the certain levels. And if GDB debugger places the breakpoint, and so GDB debugger checks till the breakpoint first, whether there is any error in the breakpoint or whether there is any error in the program. So GDB debugger removes the program, removes the error from the program, and then moves to the next breakpoint. In the same way, checks for the error at that breakpoint, removes the error, then go to the next breakpoint, check the errors, and then remove the errors. These are the multiple functions that the debugger or the GDB debug provides. Means how it functions: simply inserting the breakpoint and then uses the breakpoint for checking the error, so that program will be error free or efficient and effective. This says it run the program up to a certain point, then stop and print out the values of a certain variable. As I told you, it inserts the breakpoint, then insert the value or print the value, or then delete the errors from the program. There are multiple debugging symbols which are available in program or in debugging method, so that we can map the function to a variable, function, or line of source code. So first one symbol is your program instruction, that contains item name, item file, original file, number, line number defined. Then this says symbol tables may be embedded into the programs. Embedded means inserting into the programs or stored as a separate file. So symbol tables may be embedded or may be stored as a different file, as a separate file for the debugging symbol. So if you plan to debug your program, then it is required to create symbol table which will have required information to debug the program. There are multiple facts, or there are multiple problems, or there are multiple requirements which the simple table gives, that we have discussed in the yesterday's class. Then we also discussed how we can write the GDB in the compile time or at the compile time. Normally we compile the things as gcc hello.cc. .cc means it is a compiled file, so it is a, if it is run on the or executed on the Unix, that is your Linux. This is gcc hello.cc o hello. In the same way, we need to compile with the gflag. Instead of doing this is not a perfect method, this is not an efficient method. I am not saying perfect, it is not an efficient method for using the or for executing the GDB debugger. Instead we use -g hello.cc o hello. Then we also discussed about the program in which there is an error, and then debug process or debug processes for the error and then removes the error. So this is a program that contains an error, and the program is for finding the factorial or print the factorial of a number. As I told you, factorial is if I am printing or I am using 5 factorial, so that is 5 into 4 into 3 into 2 into 1. That is your factorial. That gives the output 120. This is a program that contains the error. Hash include stdi.h. Here there is an error. I am using num ij, this is I and this is j. So this is the error, means there is no condition. I is less than num. Where is the I? I is 1. 1 is less than num. That is executed by the compiler. Then we also discussed some GDB commands from the book. What are the GDB commands available? How we can use the GDB commands? The GDB commands are divided into multiple parts or multiple chunks or multiple categories, so that we can execute the GDB commands in a proper fashion. Then we also studied about the buffer overflow. What is buffer overflow? How we can use the buffer overflow? So this says in computer system, if anything goes beyond the boundary, that is known as buffer overflow. So buffer overflow, the best example is when we are accessing the array element beyond the limit. For example, I am using array 5 or A5, that is an array. So that array 5 contains 5 values, that is from 0 to 4. But if I want to access array 6, that is next to the array 5, so that will not execute, and that gives the error of buffer overflow. So that is your buffer overflow, means going beyond the boundary, going beyond the array limit and finding or fetching the value. But the array is of 5 size or 5 values, that is from 0 to 4, but we want to access value 5, but that is not possible because the array contains only values from 0 to 4. So this also gives a insecurity to the system or gives the incorrect results or crash of the system. Thus they are the basis of many software vulnerabilities. Vulnerabilities means your attacks, your viruses, your malicious codes, and can be maliciously exploited. Exploited means it can be exploited with the use of buffer overflow. This says programming languages commonly associated with buffer overflow include C and C++. So these are the two languages which are more affected by the buffer overflow. Bound checking can prevent buffer overflow. This is a method. Bound checking means check the method or check the errors at the every point of time. That is known as bound checking. Can prevent the buffer overflow. This is the example. Here buffer is a array type, array integer of array. Buffer is the array of char type. So it contains 10 values from 0 to 9. But if I want to access buffer 10, that is not possible. Because buffer 10 is not possible. Why? Because the buffer value or the buffer array contains values from 0 to 9, starting from 0 and ending with 9. But this is a method for fetching the value at 10th location. But that is not possible because the array contains from 0 to 9. This says note that index 0 to 9 can be used to refer these 10 bits of buffer. But in the next line, we index 10 was used to store the value of A. This is the point where buffer overrun happens because data gets written beyond the right boundary of the buffer. Then we also studied what are the exploitation methods or what are the exploitation techniques uh, affected by the or that affects the computer system. One is your stack-based exploitation. That is, whenever we use a stack, that is LIFO method, there are some exploitation techniques that gives the buffer overflow. That is known as stack-based exploitations. Then heap-based exploitations. That is, if we are using the memory and memory is a heap area. So if there is any error in the memory area, that is known as heap-based allocation. So we are dynamically allocate the memory by using the functions like malloc and then uses the exchange function to overwrite a program function pointer. So there are two types of exploitation. One is your stack-based, another one is your heap-based. Then what are the barriers to exploitation? What are the methods we have studied to exploitation? Then we have also discussed the topic that is your pointers. Pointer is a variable that stores the address of another variable. Then we have also studied what are the benefits of using the pointers. Means what are the benefits that is available to use the pointers in C language or pointers in any programming language. These are the multiple benefits. It reduces the length. It also refers to the function. These are more efficient in handling the array and structure, and it allows C to support dynamic memory management. This is the concept of pointer. This is the concept of pointer. We have also studied with the help of example. This is A equals to 10. So A is the name of the location and 10 is the value. This is the address. This is the location, name, value, address. Then PTR is a pointer variable. This is your PTR. It is a pointer variable that stores the address of A. So PTR is new variable, that is pointer variable. This is the address of A. This is again the address of PTR variable. And pointer is also a variable that has some address. So this is the address of pointer. This is pointer. It points to the value 10. That is A80F. This is the A value 10 and the address is 80F. So this is the pointer. This is the address of A. Then we also discuss how to declare a pointer variable and how to initialize the pointer variable. Declaration is so simple. Simply data type pointer st pointer name. Initialization is also simple. This is int pointer PTR. Then uses PTR equals to ampersand, that is address of operator A. Or we are considering in only one line, that is int pointer PTR equals to percentage %A. That is initialization and declaration together. Then we also discuss what is dereferencing of a pointer. That is how we can use the star operator or asterisk operator, indirection operator for using the pointer. So whenever we want to fetch the values, whenever we want to fetch any value with the help of pointer, with the help of address, that is known as dereferencing of the pointers. So these are the multiple examples for printing the value of A. These are the multiple examples we have discussed to print the address of A, and this is for address of B. Then we also discuss what are the pointers and how we can use the pointer and how we use the pointer with the help of arrays. Then we also discuss how we can use the structure in the pointer. That is how we can use the pointer with the structure or structure with the pointer or structure within the pointer. This is the example we have discussed yesterday. Then we also discuss how we can access with structure member with the pointer by using the arrow operator. This is also example. Then we also discuss how we can perform arithmetic operation on the pointer. That is, arithmetic operation means addition, subtraction, multiplication, division. That is how we can apply the pointer arithmetic, that is arithmetic operations on the pointer. These are the multiple examples. Int star I plus plus. That adds, or this adds 2 bytes, because int I is of int type and int takes 2 bytes, so it adds of 2 bytes each. This is float, this is double. So that's all for yesterday's session. Now, today I'm going to start with your next topic, that is x86-64. That is an enhanced version or extended IA32 to 64 bit. As this paragraph says, Intel IA32 instruction architecture, set architecture, that is ISA, has been the dominant instruction format for the world computer for many years. It has been a platform for the most Windows, Linux, and even Macintosh computers. But it uses only 16-bit instruction. This is 16-bit instruction. Then next is a shift is underway to a 64 version of the Intel instruction set, originally developed by Advanced Micro Devices, that is your AMD, named as x86-64. So this is an enhanced version of the IA32 that is of only 16-bit, but the enhanced version is of 64-bit, and that is known as x86-64, that is developed by Advanced Micro Devices, that is your AMD. So we can also know this as AMD 64. Then what is the history, or how we can use, or what is x86-64? So now let's see with the help of slides what is x86-64. x86-64 is also known as x64, x86 underscore 64, and AMD. As I told you, AMD 64. It is a 64-bit version of the x86 instruction set. As I told you, it is a 64-bit version of the x86 instruction set. It supports firstly larger number of amounts, that is theoretically 2 power 64 bytes or 16 exhibits of virtual memory and physical memory that is possible on its predecessors, allowing program to store larger amount of data in the memory. So that is used for storing the larger amount of memory, that is 2 power 64 or 16 exhibits. Then next point says, or next line says, the original specification was created by AMD. Means originally it is created by the AMD and been implemented by AMD, Intel, VIA, and others. It is fully backward compatible with 16-bit and 32-bit. Means it is not that I am using x86-64 on one machine that is not supported by IA32. No, it's not possible. But it is compatible with 16-bit and 32-bit. That is x86-64 is compatible with IA32 and the 32-bit operations or 32-bit instruction also. Because the full x86, 16-bit and 32-bit instruction sets remain implemented in hardware without any intervening emulation. Existing x86 executable run with no compatibility or performance penalties. Whereas existing applications that are recorded to that advantage of new features of the processor design may achieve performance improvement. This paragraph says x86-64 is developed by AMD and it is of 64-bit register that is compatible with 16-bit as well as the 32-bit registers. Then what is the history? Means how x86-64 comes or how AMD 64 comes. So AMD 64 was created as an alternative to the radically different IA32 or IA64 architecture designed by Intel and Hewlett Packard. That is, IA is designed by the Intel and the x86 designed by AMD. Originally announced in 1999 with the full specification in August 2000. So it is fully developed in the August 2000. The AMD 64 architecture was positioned by AMD from the beginning as an evolutionary way to add 64-bit computing capabilities to the existing x86 architecture. So this is positioned or this is developed by AMD from the beginning as an evolutionary way to add 64-bit computing capabilities to the existing x86 architecture as opposed to Intel approach of creating an entirely 64-bit architecture with IA64. So IA64 is provided by the Intel, that is of 64 bits, and there is an enhanced part that is known as AMD64, that is also for 64-bit register, but it has enhanced capabilities, enhanced versions, and the enhanced computing capabilities or the power tool to use the AMD64. The first AMD64 based processor, the Opteron, was released in April 2003. So this is one of the name of the AMP based processor, that is known as Opteron, that is launched or released in April 2003. So this is the history of AMD, how it is developed. Prior to AMD, what is the tool or what is the architecture that is used for creating the programs in assembly language. Next, x86-64 architecture. So this is their history. This is over many years since introduction of x86 in 1985. The capabilities of microprocessor has changed dynamically, dramatically. This is this is the history. The 32-bit size of IA32 has become a major limitation in growing the capacity of microprocessor. So IA32 has some limitation due to the growing stage of the microprocessor. So it is the time to develop or it is the time to enhance the IA32, that is enhanced by using the x86-64. This says they must write code using out-of-core algorithm which resides on the disk for processing. Further, progress in computing technology requires shifting to a large word size, that is of 64 bits. In fact, 64 bits machine has been available for some time. So this is 64-bit machine is available in 1995 or launched in 1995. At the time, however, Intel was not a serious contender for the high-end computer. So this is the history, how we can use the history. Meanwhile, Intel architecture named advanced micro or devices saw an opportunity to exploit or saw an opportunity to advance and hence IA64. This is AMD64, this is the history. Then overview of x82-64. The combination of the new hardware supplied by Intel and AMD and the new version of GCC targeting these machines makes x86-64 code subsequently different from that generated for IA32 machine. The main features for x86 are pointers and long integers are 64-bit long. Integer arithmetic operations support 8, 16, 32 and 64 data type. Second point says the set of general purpose registers is expanded from 8 to 66, 8 to 16. Much of the program state is held in the register rather than on the stack. Means we are using register rather than stack for implementing the x86-64. Conditional operations are like conditional operation means if-else condition are also applied in the x86-64. Then floating point operations is also applicable in the x86-64 for implementing or for adding or for doing the calculations in x86-64. Next is your architecture of the or x86-64 architecture. Architecture means how it is built or what is the specification, what are the internal part of a x86-64. This says assembly language is the lowest level of abstraction to the CPU without actually dividing into machine code specification. As a result of this fact, assembly language is directly dependent on its platform. For example, x86-64 assembly language is not going to be the same as ARM assembly or MIPS assembly or even x86 assembly. x86-64 refers to 16-bit architecture that is used in AMD. So this is the same concept. It is of 64-bit architecture that is used in AMD and Intel processor. It is an extension developed for the 32-bit x86 platform. This is the most important line. It is an extension for the 32-bit, that is IA32-bit x86 platform. It is worth mentioning that there are some subtle differences between AMD and implementation. Subtle means there is a small differences between the AMD and the Intel implementation. The area of overlap for the two platforms is known as x64 assembly, which is what we will be dealing with in the architecture or article. There are some advanced topics that deals with hardware specific capability, which I will not be covering here. Next, what are the features that the x86 or that x86-64 provides? First, it is of 64 bits integer capability. So one of the main feature of the x86-64 is that it is of 64-bit integer capability. This says all general purpose registers, that is GPR, are expanded from 32 bits to 64 bits, and all arithmetic and logical operations, memory to register and register to memory operations etc. can now operate directly on the 64-bit register. So the main feature or the main capability of the x86-64 is that it is of 64-bit register or it is of 64-bit integer capability. Pushes and pops on the stack default to 8-bit strides, means push and pop operations on the stack can be by default up to 8-bit strides and pointers are 8 bits wide. Then next feature is where we can use additional features in x86-64. Beyond the IA32 registers, means in access to the IA32 registers, we can use or we are able to use additional registers in x86-64. This says in addition to increasing the size of general purpose registers, the number of named general purpose registers increased from 8 to 16. That is EAX, these are used in x86, that are increased to 16. These are the more additional uses that is used for performing the operations. Then next is your larger virtual address space, means the space is also advanced. As the bits are advanced, so the space for the memory in the computer is also increased by using the AMD 64 architecture. So this says this defines a 64-bit virtual memory address or format of which the lower order or the low order 42 bits are using current implementation. Then larger physical address space in legacy mode. So first point, the prior point is that it is of large or it is of much larger virtual address space. Next point is that it is of or it contains more physical address space in legacy format or legacy mode. So it says when operating in legacy mode, the AMD 64 architecture supports physical address expansion or extension, that is PAE mode, as do most current x86 processors. Then next point says instruction pointer relative data access. So instructions are also used as a reference for the data reference in the AMD x86 or AMD 64. That is, it makes the position independent code and it is often used in shared library and code loaded at the runtime more efficiently. So these are the multiple features, that is there is a larger virtual address space, there is a larger physical memory, there are more pointers used or there are more application used for pointers. It is a 64-bit integer capability and there are additional registers used in x86-64. Then next part is your data type. This says Figure 34 shows the sizes of different C data type for x86-64. Till now we have covered different data types for IA32. Now these are the data types for x86-64. You can see the names are same, but the assembly code suffix and the Intel data type, and this is of x86-64 data type. This is of IA32 and this is for x86-64. This compares them to the sizes for IA32 operations or IA32. We see that pointers require 8 bytes rather than 4. So let's take a quick review of the table. Char, same, 1 byte, 1 byte. Short, 2 byte, 2 byte. Int, 4 byte, 4 byte. Long int, 8 byte, but here only takes 4 bytes. So it will increase from 4 to 8. It is of 32 bit, it is of 64 bit. Then long int, it is of 8 bit, it is also of 8 bit. Then char pointer, it is of 4 bit, it is of 8 bit. It will extend or it will increase from 4 to 8. Then float, it is of 4 bit, it is of 4 bit. Double, it is of 8 bit, it is of 8 bit. This is 10 by 12. There are 10 scenarios and the total values are 12. Here total values are 16 or the addition are 16. This is the comparison. This will increase from 4 to 8. This is increased from 4 to 8 and this is also increased from 4 to 8. So this is also discussed in this paragraph. These are known as quiet words by which we are ability to access 2 bar 64 bytes or 16 extra bytes of memory and so on so on. In practice, most machines do not really support the full address range. The current generation of AMD and Intel x86 machines support 256 terabytes. And these are the multiple parts which we can use in x86-64 version. Then assembly code example. This is the assembly code example. Now let's see in your book what is data type. This says figure 1 shows the sizes of data type. This is figure 1 for x86-64. This is for char 1 byte, short 2 byte, int 4 byte, unsigned int 4 byte, long int 8 byte, unsigned long 8 byte, char 8 byte, float 4 byte, double 8 byte, long double 16. And these are the various suffix. This is your Intel data type. These are the multiple bytes that is required, or these are the data type that is able to store the different data with different capacity. Like char takes 1 byte, short takes 2 bytes. In the same way, multiple C declaration and multiple data types of x86-64. So this is shows this. Comparing these to the IA32 sizes, we see that pointers shown as data char type char pointer require 8 bytes rather than 4. As I discussed with the help of book, that is, it takes 8 bytes as compared to the as compared to the 4 bits or 4 bytes. In principle, this gives programs the ability to access 16 extra bytes or 16 extra bytes of memory. So this is extra bytes of memory, 16. Then this is also discussed 4 gigabit, what we have covered. In practice, most machines do not really support the full address range. The current generation of AMD and IND Intel x86-64 machines support 256 terabytes, that is 2 power 48 bytes of virtual memory. But allocating this much memory for pointer is a good idea for long-term capability. Then we also see that long data type changes from integer to 64 bits or 64 bits. That is your 64 bits means 1 bit equals to 8 bits or 1 byte equals to 8 bits. So this is of 8 bytes. That is of 64 bits. So long takes 8 bytes. Whereas a 32 bits unsigned value can range up to this. As with IA32, the long prefix also changes the floating point double to the 80 bit format. So long takes 8 bytes. In the same way, double takes more than 8 bytes. That is of 16 byte of as compared of 12 bytes of IA32. So x86-64 contains 16 bytes as compared to the IA32 that have only 12 bytes. So these are the multiple examples, or these are the multiple data types, multiple C declaration that is used in x86-64. These are the multiple values or data type or the capacities of bytes in C declaration. The main features includes the main features of data type or the table contains or includes pointers and long integers are 64-bit long. As I told you, if you see the table, this is of long int, this is of 8 bytes, and 8 bytes are equals to or is equal to 16 bits. That is, pointer and long integers are 64 bits long. Integer arithmetic operations support 8, 16, 32, 64 data types. The set of general purpose register is expanded from 8 to 16. So whenever we use the register, it will extend the area, or it will extend the byte from 8 to the 16 bytes. Then this is much of the program state is held in the registers rather than on the stack. Integer and pointer procedure argument up to 6 are processed via register. This is whenever we are using the stack, that there are 16 or 6 bytes available that are used to pass via the registers. Some procedures do not need to access the stack at all. Then we are also implemented, or conditional operations are also implemented using conditional operators like question mark when possible, yielding better performance, means it gives better result for storing the output or for displaying the output. So conditional operators is also used in x86-64 for comparing the result or for giving the condition, and based on the condition gives the output. That is of x86-64. Then next point says floating point operations are implemented using a register oriented instruction set rather than the stack based approach supported by the IA32. Now let's see in your book. This is the assembly code, or this is the code that shows multiple data types like long int sample. That is, sample is a function name. It is of type long int that contains multiple arguments. That is long int pointer xp, long int y. This is where simple pointer or simple variable that is of type int long, and this is your pointer variable that is xp, that is also of int float or the float int. Then the explanation or the definition is we are also declaring, or we are declaring t as a pointer that stores the pointer variable xp and add the value of y. Then storing the output of t to the xp, then return the t. This is the assembly code, and this is the code in assembly language. How we can first of all push, then move, and then pop the operation. Means first of all push means inserting the values, then create the frame or create or move the instruction from one address or from one register to another register, then also move the address or the content from one location to another location, and then pop means remove the or restore the frame pointers. These are the multiple explanation, or these are the points that explains the IA32 or x86-64. Then next point is you are accessing the information, means how we can access the information in x86-64. So we are able to access, or we can access the information by using the general purpose register that is available under, or that is available in x86-64. This is compared to the address for IA32, we see make a lot of difference. So first point is that first point says the number of registers, means how we can access, or what is the difference as compared to the IA32, how we can access the information. The main point is that the number of registers has been extended or doubled to 8. In IA32, we have used the registers as 8 or the number of registers as 8. In x86-64, it increased to or it doubled to 16. All the registers are of 64 bits long. It is an extension of IA32 register. These. The new registers are this one, this one. So, how we can access the information? By using either these registers or two new registers are also added, either using that register. Then third point says the low order 32 bits of each register can be accessed directly. So IA32 is of 32-bit registers and x86-64 is of 64-bit registers. So the low order can be accessed directly. Then next point says the low order 16 bits of each register can be accessed directly. In the case of IA32, the word size version of the new registers are named as this. So this says the difference between or compare between the IA32 and the x86-64. That is how we can access the information with the help of IA32 and how we can access the information with the help of x86-64. Then the next lower version or the next lower part, 8 bits of each register can be accessed directly. That is also true in IA32 with only using 4 registers. These are the 4 registers. For backward compatibility or compatibility, the second bit of or second byte of register, that is this one and this one, can be directly accessed by an instruction having single byte operand. So this says how we can access the information. There is a difference between accessing the information in IA32 and in x86-64. These are the multiple memory locations where we can access the information, or registers where we can access or we can store the information. This is stack pointer, coalesce, first argument, second argument, fifth argument. These are the integer registers. This is the existing 8 register extended to 64-bit versions. These are the multiple instructions. First of all, move ABSQ, that is move absolute quad word, that is absolute quad word to this one, that is I stand to R, that is move the I word to the R. These are the data movement instructions. This is the example. So now let's start with different instructions or the different instruction that is available in assembly language. But before this, let's take a 10 to 15 minutes break and then come back and then start with your arithmetic instructions. Or what are the instructions that is available in x86-64. So let's take 5 to 10 minutes break and then start with the next topic, that is arithmetic instructions. Or what are the instructions that is available in x86-64. So let's take 5 to 10 minutes break. Now let's start with the next topic, that is arithmetic instructions, or what are the instructions that is available in assembly language or x86-64. So the first instruction in x86-64 is arithmetic instruction. Arithmetic instruction means either performing the arithmetic operations like addition, subtraction, division, multiplication. So this says arithmetic instruction includes or takes 2 operands. As I told you, what is operand? On which we can perform the operation, that is known as operand. A destination and a source, means where the output will arrive or where the output will store, that is known as destination, and the source is from where the input or from where the performance will execute. The destination must be a register. The destination must be also a register or a memory location. The source may be either a memory location, register, or a constant value. So source may be anything. It may be memory location, it may be register, it may be constant value. But the condition is that destination must be a register or memory location, not a constant value. Note that at least one of the two must be a register, because operations may not use a memory location as both are destination and source. This says at least one of the two must be a register. One of the two means either destination or the source must be a register. This is the mandatory condition, because operations may not use a memory location as both are destination and source destination and destination. That is, operations may not use a memory location for both source and the destination. This is add source src destination. This is add destination source. This is your Intel syntax, this is your GAX syntax. So how we can add? The first operation is add, this is source, this is destination. This says this adds source to the destination, that is src to the DEST, that is destination. If you are using the NASM syntax, then the result is stored in the first argument. If you are using the GAS syntax, it is stored in the second argument. This is your source, this is your destination. The output will be stored in the destination, and the condition is that the operations must use or may not use a memory location for both source and the destination, because it does not perform the operations on both the values that is either stored in source and the destination. Then next instruction or the next part of the arithmetic instruction is your SUB, that is your subtraction. The syntax is SUB source destination, SUB destination source. This is your GAS syntax and this is your Intel syntax. So here the output will be stored in the DEST, that is your destination. So subtract source then destination means subtracting the value of source to the destination and stores the output, gives the output in the destination figure. It must be of or it may be of memory reference. This is like add, only it subtracts source from the destination, that is C destination, that stores in destination minus equals to source. Next argument, next instruction is your multiply, that is your MUL, then argument. The argument may be of any register, may be of any byte, depending on the AX register. This says this multiply argument by the value of the corresponding byte length in the AX register. This is operand size 1 byte, 2 bytes, 4 bytes. This is other operands AL, AX, EAX. This is the highest part, AH, DX, EDX. This is the lowest part. So how we can multiply? By using the multiplication or mul keyword and then the argument. And how we can add? Simply uses the add keyword, then source and the destination, and the output is stored in the destination. In the same way, when we are using subtraction, using the sub keyword, that subtraction part or the subtraction output is also stored in the destination. Next is your divide, that is using the keyword div, then argument. This says this divides the value in the dividend register or registers by ARG. See the table below. This is the table that is used for dividing the values. This is divisor size, that is 1 byte, 2 bytes, 4 bytes, dividend AX, DX AX, EDX AX. These are the remainder that we stored. Question that is stored in which register? AL, that is of 1 byte, AX and EAX. The colon indicates means concatenation or show the concatenation. We are using or we are adding the values or concatenates the values of the register, that is AX and DX. Then this is also a column that is of 4 bytes that adds the value or concatenates the value from or EDX to the EAX. This means that EDX are the bits 32 to 63 and EAX are the bits from 0 to 31 of the input number, with lowest bit number being less significant in this example. Next part is your increment and decrement. Next argument or the next instruction is your increment instruction. So So the syntax is that INC, that is increment ARG, that is your argument. This increments the register value in the argument by 1. So whenever we use INC ARG, so it increases or increments the argument value by 1. That performs much faster than add ARG 1. Then decrement, this is your increment, this is your decrement. So INC ARG, then DEC ARG. This decrements the register value in the argument by 1. So this increases the value, this reduces the value by 1. Performs much faster than SUB argument 1. So these are the multiple instructions that we are using while using the x86-64. Now let's see in your book. These are the multiple instructions. These are the data movement instruction, how we can move the data. These are the arithmetic instruction which I told you. This is the example of the C language of the C function, that is long int g1 int x int y, long int t1 long int x plus y. Then long int t2 equals to long x plus y. This is for 64-bit addition and this is for 32-bit addition. Then return the value by concatenate the value of t1 and t2. Then this says given that integers are of 32 bits and long integers are of 64 bits. These are the special arithmetic operations. Now, next part is your control. Means how we can control the instructions or how we can control the flow of program in the x86-64. This is the control instructions and methods of implementing control transfer in x86 are same as those in IA32. We have discussed multiple controls like conditional operator or the multiple operators, fun operator by using the control statement, that is very similar to the control part. So this is very similar to the control part. As shown in figure 38, the two new instructions, that is cmpq and testq, are added to compare and test quad words. That is what quad words for adding we are using for compare and test, that is cmpq and testq. So this GCC uses both conditional transfer and conditional control transfer, since all x86-64 machines support conditional moves. So these are the multiple instructions or the multiple instructions of controlling. This is CMP S2 S1, that is based on S1 and S2. It compares quad words. This CMPQ compares quad word. Then test S2 S1. This is the testing purpose. This is for testing purpose, that is S1 and S2. Test, then test Q, that test quad word or the test quad word. This is the IA32 version example. This is the assembly example for the IA32. This is the example for the x86-64 version. These are the multiple examples how we can use the control in the assembly language, that is a part of x86-64. So control instructions and method of implementing control are essentially the same as in IA32. Two new instructions, CMP and testq, as I discussed, are added. These are the two new instructions, CMPQ and testq. Next, how to use or what is conditional boom instruction. This starting with Pentium Pro in 1995, recent generations of IA32 processors have had conditional move instruction. Means how we can add the conditional move instruction that either do nothing or copy a value to a register depending on the value of the condition codes. This provides an alternative way of implementing conditional operations that can be subsequently faster than using branching code. So whenever we use conditional instruction or conditional move instruction that are more faster than using the branching code. Next day, for years, these instructions have been largely unused. So GCC used them because they are using the backward compatibility. So the advance of or the version of x86-64 allows the compiler writer to forego this compatibility requirement. So this moves the cursor or this moves the compiled version of the x86-64. This is your conditional move instruction. This is as we saw in IA32 generated by GCC, the conditional statement using the if. Here in x86-64 we are using conditional operators as question mark and then there is a colon. As an example, consider the following general form of assignment and conditional expression. This is V equals to test expression, that is your condition. If this condition is true, then this statement will execute, otherwise this statement will execute. So the output is stored in the V variable. So V is a variable that is equals to test hyphen extr, that is your expression, that is test expression. Then question mark, then there is a statement, colon, there is a statement. So if this condition is true, then this statement will execute, otherwise this statement will execute. And the output is stored in the V variable. The compiler generates codes having a form shown by the following abstract code. If not testq expression go to else part, V equals to then expression go to done. This is your else part, means if the operation is not correct, go to directly else part. This statement will execute. Then done, that is go to done. V equals to this. Done has a value that gives the expression, that gives the then expression value. That's stored in V also. Then the next topic is procedures. As I told you in the last class or the last class, procedures in IA32. In the same way, procedures are used in x86-64. So this is, we already seen in our code example or sample that the x86-64 implementation of procedure codes differs from the IA32. By doubling, means double the instruction from 32 to 64, the program needs not be so dependent on the stack for storing and retrieving the procedure information. This can greatly reduce the overhead for procedure calls and returns. Here are some highlights of how procedures are implemented or how procedures are implemented with x86-64. This is how the procedures are followed. First one is your argument, that is up to first 6 are passed to procedures via registers rather than on the stack. Means we are passing the argument to the procedure by using the register rather than the stack. This eliminates the overhead of storing and retrieving values on the stack. Then next point says the call instruction stores a 64-bit return pointer on the stack. Then next says many functions do not require a stack frame. Only those functions, means not every function require a stack, but only those functions require a stack that uses or that keeps a local variable in registers. Then next point says functions that are able to access or that can access storage on the stack can be up to or is going up to 128 bytes beyond the current value of the stack pointer. This allows some functions to store information on the stack without incrementing or decrementing the stack pointers. So these are the multiple points while which we are considering while using the x86-64. Next point says there is no frame pointer, that is relevant to the stack pointer by using the IA32 version. Then next point says, as with IA32, some registers are designed as fully saved registers. There must be saved and restored by any procedure that modifies them. Then how to pass the argument, that is your argument passing. This says up to 6 integral, that is integers, example integers and pointers, argument can be passed via register. So how we can pass? We can pass by using the 6 integers integral, that is by using the 6 integers and the pointers via registers. The registers are used in a specified order and the names used for register depends on the size of the data type we pass. This is shown in the diagram how we can pass. We can pass up to the 6 integral, that is combination of integer and pointers. So this is for 8 bits, this is for 16 bits, this is for 32 bits, and this is for 64 bits. This is for 8 bits, these are the multiple registers, these are the register for 16 bits, these are the register for 32 bits and 64 bits. This is how we can allocate and how we can give the argument to the different registers. These are the registers, the same concept. These are the same points. These are the diagrams. We are using only 6 registers and the bits are of 8, 16, 32 and 64. And the names of the registers are this one. This is used for 8 bits, this is used for 16 bits, 32 bits and 64 bits. These are the registers for passing the function arguments. Then next concept is your argument passing. Same, up to 6 integers are used for passing the argument. This is the function, C functions, how we can pass the argument. This is void proc procedure long A1 long pointer A1 P. So this is the pointer variable and this is a simple variable, that is an integer and pointer. Then int A2, int pointer A2P, short, char, char. And this is the definition, that is we are using the pointer for adding the value. This function is also implemented in x86-64 as this one. Argument pass A1 in RTI. This is your register RTI. We can use the registers for storing the value, that is RSI, EDX, RCX, R8W, RM or R9. This is your example. Then next part is your stack frame. Means what is your stack frame while using the x86-64. We have already seen that many compiled functions do not require a stack frame. As I told you in x86-64, there are multiple functions or there are multiple examples which we have discussed that do not require a LIFO method, that is your stack frame. If all of the local variables can be held in registers and the functions does not call any other functions, sometimes referred to as a leaf procedure, that is without any functions, in reference to the tree structure of procedure code, then the only need for the stack is to save the return pointer. So the only method or the only way or the only use for the stack is storing the return pointer whenever there is a leaf pointer or there is a leaf function or the tree structure of the procedure code. So the only requirement or the only need for the stack is to save the return pointer. Save the return pointer means with the pointer returned it can save the value. It means stack can save the value and give the output. On the other hand, there are multiple reasons a person may use a stack frame. There are multiple other reasons. There are too many local variables to hold in register. Some local variables are array or structure. That is why we are using or why we are acquiring or why we require a stack frame. The function uses the address of operator, that is your ampersand operator, to compute the address of a local variable. Next reason is that why we require that the function must pass some arguments on the stack to another function. Then next one is the function need to save the state. State means whether it may be in running state or it may be in static state. Running means executing the values of a wholly save register before modifying it. Now let's see in your book. This is your stack frame. There are several reasons why we require a stack frame. There are too many local variables. Some local variables are array or structure. This is the same example what we have covered. Same points. This is the example. We are using integer value as 1. This is integer value as 2. Short value as 3. Short value as 4. This is your procedure, that is we are using ampersand, that is pointer. We are using normal variable, that is x1, x2, x3, x4. Then returning the value, that is from x1 plus x2 into x3 minus x4. This is a GCC code for the x86-64 code. These are the multiple examples for the stack frame. This is the diagram before calling to the procedure and after calling to the or during call to the procedure. This is x2, x3, x4, x1. This is x1, x2, x3, x4. These are the bits 0, 8, 16, 24, 28, 31, 0, 8, 16, 24, 32. Then register saving convention, that how we can save the program or how we can save the instructions in the register. That is known as register saving conventions. These are the multiple examples. This is a diagram or this is the example for finding the factorial. This is the next example for finding the factorial. Next is your data structure. That is how we can use the data structure in x32, x86-64. As we have discussed, there are multiple data structures like long, double, int. Then concluding observation about x86-64. So the conclusion of all the methods, that is both AMD and the other authors of GCC deserve credit for moving x86 processor into new era. Means both are giving the credit or both are giving the privilege that moves or that's credit for moving the x86 processor into a new era. New era means into a new world. The formulation of both x86-64 hardware and the programming convention changed the processor from one that relied heavily on the stack. So it changed the procedure that basically in previous mode relied on the stack, and there are some limitations so that stack will not cope up. So it will remove the procedure and goes from x86 to 64. Finally, x86 has thought of the ideas developed by RICH processor in the early 90s. This is the so actual for today's session. Next topic is your machine level representation of floating point that I will discuss in the next class. So that's all for today's session. Now, if you have any doubt, then please clear the doubt. But before that, let's take a quick review of the today's class. That is what we have covered in the today's class. So let's take a quick review. In today's class, we have discussed about one topic, that is x86-64. x86-64 is an enhanced version of the IA32 32, that is of 32 bits. The enhanced version of the advanced version of the IA. This is also known as x64, x86-64 or AMD 64 because it is developed by AMD, so it is known as AMD 64 or also known as AMD 64. The original specification was created by AMD and been implemented by AMD, Intel, YA, VIA and others. Then we also discussed what is the history and how AMD built or developed the x86-64. Then we also discussed what is the architecture, what is the internal part of the x86-64. Then what are the features while using the architecture, that what are the features that the x86-64 provides. There are multiple features. We have considered only 5 features. That is, there is a large physical address, large virtual address, additional registers, 64-bit integer capability. Then next topic is your data types. Means what are the data types or what are the types of data that is available in x86-64. There are multiple sizes of different C data types for x86-64. As compared to the IA32, we see that pointers are added in x86-64. Then we have discussed what are the registers available in this one. These are the multiple new addresses that join, that is long is converted from 4 to the 8, that is it is incremented from 4 bytes to the 8 bytes. Then what are the features that is available while using the data type? These are the multiple features. Then we also discuss instructions or the multiple instructions that are using while using the x86-64. So the first is arithmetic operation or arithmetic instructions that is used for performing the arithmetic operations like add, subtract, divide, multiply. So first one is the addition operation, that is ADD keyword, SRC, source and the destination, and the output are always stored in the destination file. Then SUB, subtract, then MUL, multiply, argument. Then we also discuss about the divide argument. These are the argument register, these are the argument values. Then increment and the decrement. That is how we can use the increment value and how we can use the decrement value. The syntax is INC ARG DEC ARG. Then we also discuss what are the control or what are the control tools available in x86-64. Then we also discuss conditional move instructions, how we can move the conditional instruction by using this operator, question mark and then colon operator. This is condition. If the condition is true, the first then expression will execute, otherwise else expression will execute. Then we have discussed about the procedures. So procedure are nothing but the combination or the short form of the program that are using in x86-64. These are the multiple highlights or the multiple features of using the procedures in x86-64. Then we have also discussed how to pass the argument in procedure. These are used by using the 6 integral, that is using the 6 integer and pointer, by using the registers in every 6 pointer and integers. Then we also discussed what is a stack frame, how we can use the stack frame, that is how we can store the value of x86-64 into the stack frame. So that's all for today's session. Now if you have any doubt, then please text the doubt and I will answer you. Now, there is one important announcement. Please listen, important announcement. From Monday onwards, your class timing will be shifted from 12:30 to 11:30. that is 1 hour prior to the current timing. I'm repeating again, your timing for the Monday is from Monday onwards is from 11:30 a.m. That is from 12:30, it moves from 12:30 to the 11:30, and the mail will be sent to all of you for your reference. So that Monday's class, or from Monday onwards, the class will be on 11:30 a.m. The reason is that due to some clashes means due to some clashes in the meetings that is going on in the institute, in the organization, in the Mercury solution. So there is some clashes. So there is some disturbances in the network. There is low bandwidth, there is no internet access, or there is a less speed. So for avoiding that clashes, or for improving the efficiency of your video lectures, we are moving the timing 1 hour prior, that is from 11:30 to 1:30 p.m. 11:30 a.m. to 1:30 p.m. that is of 2 hours lecture. So I think this is clear to everyone. So that's all for today's session. Thank you everyone. Now if you have any doubt, then please text the doubts and I will answer.